Well, thank you. I would like to thank the CIMAT at the University of Guanajuato for giving me the opportunity to talk about responsible AI. And the first thing I want to do is look at the top of the presentation. You will see this link, which means that the presentation is live, so you can access this presentation from that link. Well, I'll talk a little bit about myself. And the remaining things is that I'm working now as a software engineer in a customer success team, which is a technical pre-sales team. It's a team of experts in different areas. And my responsibility there is to support sales from the machine learning perspective and search as in information retrieval. I've been working with responsible AI since for 2 years ago. It had a different name by that time. And I had the pleasure to work to be the advisor for 2 master students in Denmark, where we were working with fairness in recommendation systems and devising metrics on how to measure unfairness in ranking results. And at the moment, we're also cooperating with the University of Oslo and Sirius, developing techniques to debug machine learning models. The agenda for today, we're going to talk, since this is a broad audience, we're going to talk a little bit about what is artificial intelligence, machine learning, and deep learning. And then we're going to have a working example for machine learning before we dive into responsible AI. And at the end, I also have some slides about research roadmaps. So since we're going to cover lots of themes and subjects, I have prepared some slides with links and how you can dive deeper into whatever sparks your interests of what I'm going to talk today. So let's talk about the challenges of using artificial intelligence. And we use artificial intelligence every day, and it has become a natural part of our lives. And we see more and more reality through the lenses of technology and algorithms. This comes both with advantages and disadvantages. And one of the problems is that these algorithms can affect us in ways that we're not really aware of. So my first example is search engines. Let's say like Google. The search results provided by a search engine can affect your judgment. And there is something called the search engine manipulation effect. By the way, I forgot to tell you that the presentation is full of links everywhere. So you can click on this and it will take you to the reference of that, what I'm telling you. So it's nice to have the slides. So in this setup, they had researchers took 2 political candidates, A and B, quite similar candidates. And they had 2 groups of people, the control group and the other one where they were presented the biased results, where search hits for candidate A were presented higher all the time over candidate B. After 30 minutes of using this search engine, you could measure that people started to prefer candidate A over candidate B. So this is a problem because you can control without noticing what people will prefer. The second example is Facebook. And the short version is that Facebook has the ability to make you feel good or bad just by tweaking what shows up in your newsfeed. So this is an experiment from Facebook engineers in 2013, where they manipulated the feeds of almost 700,000 users without their knowledge or user consent in an attempt to control their emotions and influence their moods. So what they did is, again, they divided these users into 2 groups. And to the first group, they just presented positive newsfeed, positive posts, and to the second one, just negative posts. And after a while, they started to notice that users that were exposed to the positive posts, they started also themselves to write posts with more positive loaded words, and the opposite case for the other group. So we may think we are immune to emotional manipulation, but we're probably not. And the thing is that there is this power dynamics where actors not using artificial intelligence, losing their market shares to the ones who do. So there is a strong economic incentive to use the power of artificial intelligence to increase revenue. As an example, 35% of what is sold in Amazon, and 75% of what is watched on Netflix comes from product recommendations. And you may think, what's wrong with that? Well, here are two examples of missing transparency and accountability. The one to the left is about the case in Idaho, where there is this state's Medicaid program, where they give economic support to people with developmental and intellectual disabilities. So they wanted to make the process more effective, so they introduced an algorithm to do this. And the problem was that people suddenly saw their support being cut by 20 to 30%. And when the authority was challenged on why this was happening, they came back with, well, this is a trade secret, or formula, right? They didn't want to disclose the algorithm. So it took a class action suit from the people to the government in order for them to release the algorithm. And what they did, what they found out was that the data they had used was corrupt because they were using historical records, but they had to throw out 2/3 of the data because of data entry errors and data that didn't make sense. And so they were supposed the population they were supposed to model was not really represented in the data. The second critical thing was also that while they were testing this algorithm, the organization found out that there were problems with this, but nobody did anything about that. And this is because of the bias we all have for computerized results. We don't question them. When a computer generates something, or maybe when you have a statistician who looks at some data and comes up with a formula, everybody just trusts that formula without asking, hey, wait a second, how is this actually working? So without transparency, we cannot really review what's going on. The example to the right is about missing accountability, and it's about the terror list in the States. And this is a girl originally from Malaysia with a PhD from Stanford, that she was going to fly to Malaysia and with a stopover in Hawaii to give a talk at a prestigious conference. She was a member of a student organization that has a name that is quite similar to a terror organization. And the thing in the guidelines for the FBI to add you to this terror list is that you just have to have reasonable suspicion to nominate someone. So it's really easy to get into that list. So when this girl was going to fly from San Francisco, she was detained by the FBI and interrogated for several hours until it came forward that this was just a big misunderstanding. And then she thought, okay, maybe, well, now this is over, everything is fine again. But it turned out that no, she wasn't taken off the list. She was trying to fly again and the same happened again. So at the end, it took her 10 years of litigations for her to be removed from this list. And things shouldn't be like that, really. Well, with that setup, what we're going to do now is just give you a very short introduction to artificial intelligence. And it's important to know the difference between these terms, because then we know better their strengths and shortcomings. So artificial intelligence, the field started in the 1950s, 60s as rules. And rules encompass generalizations and promote deductive reasoning to make decisions. But the problem with rules is that rules don't scale out so easily. For example, they define, if you want to define the rules, when you have a picture of a cat, to define if there is a cat in the picture, this is going to be really hard, right? So can we take the opposite approach and do some inductive reasoning and start from the data? And this is what the field of machine learning is trying to do. But it started with handmade features, and this was also very time consuming, and it didn't scale again. So inside machine learning, we have another field called representation learning, which deals with how to automatically create the features we need. And neural networks, which is an instance of deep learning, this tools are kind of the first tool that where they managed to do this in a scalable and effective way. So neural networks are universal approximators. That means that if there is a mapping from an input to an output, they will manage to approximate and generate a function for that. There are some theoretical constraints, of course, but in practice, it works very well. And of course, I forgot the I had animations on this slide. So let's look at an example of to build a cat versus dog detector. So if I'm going to build this, I would have to start by collecting pictures. I would collect pictures from cats and dogs. Then I will train an algorithm to try to recognize. I'm going to assign the label cat to the top row and the label dog to the lower row, and then we try to predict. And we see that the algorithm has a higher score for the label cat than dog, so this is good. We test again with a dog, and then we see that the algorithm will also predict correctly. So let's go to production. Let's go live with this system. What could possibly go wrong, right? But the thing is that reality is hard, and the data that comes in can be a bit different than what you trained your algorithm with. So when we see this and we show it to the algorithm is like, well, I think maybe this is a cat. And here's a nice thing to see here. What probably is happening here is that you see all our cats are white and all our dogs are black. So neural networks are really good at exploiting something we call spurious correlations. This is like correlations in the data that are really not necessarily the real thing that you need to find out to decide if this is a cat or a dog. So they take shortcuts. And this is a problem, right? So it seems that we are building really a black and white detector. But again, it also shows that data is not well represented. So typically, if I want to fix this, I would have to add new data to my training data set. And I have to train again and teach the algorithm that what is the correct label for this instance. In this case, this is a dog. So we think we have fixed the problem now. We try to go to production again, and we see something like this. And the algorithm is not, yeah, it's a dog, but not for by a big margin. So the second thing I want to say here is that if you don't have enough data, neural networks will just remember what is the correct label for this instance. And this is a problem, right? Because you don't want your networks just to remember things. You want them to generalize and to learn something. So in this case, it's really easy for us to see which data is not well represented. We're really good at detecting pictures. But if you have features, data points with high dimensional data, like, well, just it doesn't have to be many columns, but let's say 20-dimensional features for your data, it will be really hard to find out what kind of my training examples are not well represented. So there are methods to do this, but we can talk about that later. So what we have done so far is just to train an algorithm and try to predict all these things that people think when they are doing data science, like finding the hyperparameters, finding the right algorithm, modeling the problem. This fits in this red box, which we just put it the machine learning code. And people are wondering, okay, when we're gonna go live with something like this, what part of this code makes the overall system? And there is a nice paper by Google, which is in the link here in the 5%, that tells you that they did the calculation. They found out that around 5% is just what we're doing with machine learning. The rest of the code has to do with the other boxes, like data collection. You have to have a place to put your data, a place to organize it. You have to care about access management. You have to care about who's going to use the data. It has to be kind of a data catalog where you can search over what is available so that I can use it. Maybe you want to do something called feature engineering, where you want to produce features from your data. Maybe, for example, a timestamp, you want the day of the week, or you want the day of the year. Maybe you want to enrich your data set with other data set, and you have to keep track of all these things for reproducibility and for transparency. And maybe you want to train these things at scale, so it has to work also outside your computer. And you also have to think about that whenever you go to production, your users are going to use your system in a different way. So all your data that you have been using to train your model will be outdated right away when you put in production, because your user will behave differently when your model is live, because they will get recommendations or whatever your service do. So you have to have monitoring and logging and try to monitor the data distribution. When you see a big shift in the data distribution, then you know that your model is no longer useful and you have to retrain all this again. So you have to also have the tools to iterate quickly and go through all this thing quickly again to put the new version in production again. And apart from that, when you're thinking about all these things, how do I do this in an ethical way? So fortunately, the EU Commission has come up with some guidelines for trustworthy AI, where they have recognized 3 main requirements for an AI system. And the things are that it should be lawful. You have to comply with applicable laws and regulations. It should be ethical, and it should be robust. And they further break this down into 7 or more or less overlapping subjects, like accountability, privacy, transparency, that you have to continuously evaluate and address during the whole process. We won't have time to go through all of this, but I'll just focus on some of them. And you may want also tools to how to operationalize all these principles. And here's a nice link from the AI Ethics Lab, where it gives you a tool that you can use to try to put the processes in place and the questions that you need to ask to be more aware of how to be accountable with these principles. So what I like from this article is that they have a separation between core and intrinsic principles. The core principles, in this case, autonomy, harm and benefit, and justice, they are valuable for their own sake. These are chosen because they are the most widely utilized set of core principles in applied ethics, where people agree that these are, their value is not derived from something else. But we have also these instrumental principles like human control, transparency, privacy, fairness, and we value them to the extent that they protect the core values. So as an example, transparency is instrumental to uphold intrinsic values of human autonomy and justice. And accountability is not an end in itself, but rather a mean to safeguard justice by assigning responsibility and avoid harm. So let's look at some examples of some principles under autonomy. And to comply with transparency, I like this model cards from Google. This gives you a nice overview of here. What they train is a model for face detection. And they tell you, okay, this is how we built the model. These are the inputs. These are the outputs. This is the performance that we have gotten. And if you have done some bias exploration of the data set, what have you done? What have you measured? Limitations of the data set. Because with if you have all this information available and I'm going to reuse your model for something else, then I know what things you have looked into and what else do I have to do to make it work for my case. So this is a very nice practice thing to do. And it's starting to come now people are starting to use these tools. We have also explainability. Let me show you two types of explanations so that you get the idea of what we're trying to do. One aimed at end users and one for developers. So let's say that you have an algorithm that tries to predict if you have risk to develop diabetes 2. In this case, the prediction tells you that to reduce your evaluation score shows that you have high risk to develop type 2 diabetes. But to reduce your risk, you must increase your daily steps or reduce your soda consumption. And this is nice because end users don't really care how you came to that conclusion. But what they want is something called contrastive explanations. They want to do, okay, what do I do for me to lower my risk? This is what's important for me. The key feature here is that you have to use features that are actionable. In the following example, for example, we have that your application for an eye surgery was not accepted. You have to change either your eye color to blue or your birthplace to Sonora, from Sonora to something else to change the decision. And this is an example that illustrates that you can also use these explanations to understand when your model is misbehaving. Probably you have more patients with blue eye color that need more eye surgery because of something, and they probably come from Sonora or something, usually. But to give this insight is not actionable for the user because you cannot change your eye color or your birthplace, right? So this is not good. For the developer, you are probably not really interested in what to do with the decision, but more like, is your model using the features in the correct way? And here is an example of what we call explanations for developers. It doesn't really matter what the domain that we're using, but we have the model is doing a regression and it's predicting a value of 24.41. What we see is a base value here. This is the kind of the average prediction value, and it will tell you this is a technique to calculate how which features are pushing the value up or down the base value. And so as a domain expert, I can validate that my model is really using the correct features in the right way. But the problem here is that to produce these explanations, it demands lots of calculations and sampling. So if you don't do the sampling correctly, you will maybe not catch how the model is really taking the decision, because explanations are really just an approximation. It's a proxy to try to understand what's happening in neighborhood of the data point. And the second thing with the contrastive explanation is like, if you're the user that got the prediction that you're gonna have a high risk for type 2 diabetes, and you want to change that, let's say that after 2 months you come back and said, okay, I have increased my daily steps and I have reduced my soda consumption. But then maybe you have changed your model, you have deployed newer versions of your model, and now the model will tell you you have a high risk because of something else. How do you keep track of this, right? This had been an application for a loan, and it tells you what things you had to do to get the loan approved. And you come after 3 months with that, and they tell you something else. What happens then legally, right? So these are issues that we still haven't figured out. What do we do? Lastly, I just want to talk a little bit about justice and fairness, because this fairness is really a hard problem. It's a highly context dependent and domain specific. Sometimes I want to treat people similarly on the basis of relevant features, given their current degree of similarity. Maybe I also I'm concerned in organizing the society in such a way that people that have equal talents and ambitions will be able to achieve equal outcomes during the course of their lives. Or maybe I'm interested in something in between, where I want to treat people that are dissimilar, I want to treat them similarly because I want to compensate for past injustice. So this is hard, and mathematically we have already more than 25 definitions, and it's difficult to choose when to use the correct definition. So what people would usually do is they base the definitions on protected attributes or measures of similarity, or they want to use to mean, for example, that the score means the same for different groups, or maybe they want that the algorithm makes errors at the same rate for different groups. Fortunately, there are tools that can help you like try to decide in your use case, this is for classification only, but what are you trying to do? And it will guide you a little bit in which metrics you can use to measure that. But you would wonder, isn't the point of artificial intelligence to discriminate if I'm gonna separate these from those? And yes, it is. But when this becomes objectionable when you put certain privileged groups at a systematic advantage and certain unprivileged groups at a systematic disadvantage. So when it's not relevant in the domain, then you are discriminating for the wrong reasons. And this is something that you have to measure. So at the end, to conclude a little bit, if you are more interested in explainability, I have this list of resources that you can follow upon, and the same for fairness. And this is from a workshop that we gave in June on how to operationalize fairness. And the tool from IBM, IF360, is one of the best ones at the moment to work on fairness. And I also put Microsoft's and Google's libraries because they are catching up quite quickly. If you're interested in how to put machine learning in production, what are the best practices? Here are some examples. And if you want to do ethical assessments of algorithmic assessment, here are also some resources that can help you dive deeper. Navigating this field of machine learning is hard, so that's why I also put some links to how to browse the state-of-the-art papers. And the connected papers also, it's a nice link because then you can find a seminal paper and then see how people are using those results further. So if you're going to remember something for this talk, I hope that you remember that artificial intelligence is a process and not a tool. AI is not really an objective math. The biases of the people generating the data, creating the algorithm, and deploying the system are all implicitly injected into the technology. So you can't use just technology or math alone to make artificial intelligence fair. That's a naive thinking. So that's why evaluating the trustworthiness of artificial intelligence is really important to minimize risk. That's what I had. If you have any questions.
Thank you. Questions? I'm looking at the chat. Nothing yet. But sometimes this takes a few seconds. Or maybe if somebody wants to say something, maybe you can unmute yourself and you can say that aloud. Do you want to? You prefer that over writing?
Y que las preguntas ya pueden ser en español para que no les dé pena preguntar.
Ah, claro.
También, claro.
Muy bien.
Bueno, yo quiero... Ay, perdón.
Ah, muy bien. Adelante.
Sí. Digo,
quería preguntar, estos algoritmos que nos asustan a todos de que nos escuchan y luego nos muestran los productos, más o menos cómo funcionan. O sea, que te escuchan platicando de algo y ya después te empieza a aparecer como la publicidad, ¿no?
Como por ejemplo, si tienes prendido Facebook y tú hablas sobre una televisión nueva y de repente te empiezan a aparecer anuncios de televisiones nuevas por todos lados. Todas las conversaciones, por ejemplo, si usas Google Home o si usas Siri o Amazon Alexa, las conversaciones son grabadas. Y por ejemplo, en el caso de Amazon Alexa, los que trabajan, tienen un montón de gente trabajando, escuchando las conversaciones y haciendo las transcripciones para que Alexa pueda ser más inteligente. Y el problema es que esta gente escucha todas estas conversaciones y muchas veces han escuchado cosas que son criminales.
Qué
Por
horror.
ejemplo, y la gente acaba traumada, ¿no? Porque tú has firmado un NDA para donde no puedes hablar de esto, no puedes ir a la policía y entregar la grabación. Entonces, pero generalmente lo que pasa es que automáticamente tú detectas palabras y tú puedes detectar de qué estás hablando. Y si lo conectas a tu servicio de anuncios, entonces puedes servir tus anuncios más relevantes. Que esta práctica no es muy ética, claro, esa es otra pregunta, ¿no?
Sí, pero entonces son personas, no es un algoritmo que pasa como el audio o hay todo.
No estoy seguro de qué es lo que hacen, porque Amazon no te va a decir, ni Google, ni Facebook, qué es lo que exactamente hacen. Pero las personas lo único que hacen es hacer las transcripciones para tratar de que cuando entrenes tu algoritmo otra vez, sea mucho más preciso. Pero estoy seguro de que si tienen algo, seguro si hacen detección de ciertas palabras en tiempo real. Eso sí se puede hacer.
Gracias.
Pues te quería preguntar, estos sistemas que usan para, digamos, si supones que sé muy bien cómo funciona una red neuronal, ¿cómo funciona el sistema para ver que no discrimina? Ya en la práctica, ¿qué es lo que ve el usuario del sistema? ¿Cómo?
Tienes varios
O sea,
métodos.
porque me imagino que una exploración así del espacio completo no puedes hacerlo, ¿no?
No, efectivamente. Para empezar, tienes que usar los atributos protegidos, como el sexo, la edad, tal vez dónde vives, para tratar de medir, no para que el algoritmo los use para tomar una decisión, pero más que nada para ti, para hacer el análisis externo, pues, y validar. Si divides estos grupos en hombres y mujeres, por ejemplo, si tú vas a enseñar anuncios sobre ciertos trabajos, pues quieres tú cuantificar qué tantos trabajos les enseñan, por ejemplo, que a los hombres solamente les voy a enseñar trabajos con un salario alto y a las mujeres les estoy enseñando solo salarios bajos, ¿no? ¿Por qué? Porque históricamente tal vez en tus bases, en tus datos que entrenaste tu algoritmo, está representado de esa manera. Entonces lo que te haces es eso, medirlo al final, y si ves que hay un balance, hay un misbalance, lo que puedes hacer es, hay técnicas de preprocesamiento donde puedes añadir pesos a los ejemplos para que el algoritmo use más pesos en los ejemplos que tú quieres elevar y menos pesos por ejemplo, a los hombres le pones un peso más bajo y a las mujeres un peso
O
más
sea,
alto
pero en
para que se
realidad
balancee.
depende mucho de tu creatividad, o sea, de la persona que está como evaluando el sistema, no es nada automático, güey.
Sí puedes hacer cosas automáticas, pero todavía hay o sea, también puedes tú desarrollar el algoritmo que en tu función de optimización de costo, le puedes añadir términos de regularización para que preserve el balance entre los grupos, por ejemplo. Eso también lo puedes hacer. O puedes hacer cosas después de que el algoritmo hace predicciones, que es en el postprocesamiento. Porque todo depende de si tienes tu acceso a la información, a los datos de entrenamiento, tú tienes que trabajar, empiezas a trabajar tan temprano como puedas, ¿no? Haces el cambio ahí. Si tienes acceso al algoritmo y lo puedes cambiar, entonces tú puedes añadir cosas al algoritmo para que funcione un poco mejor. Pero si tú usas un API, por ejemplo, de Google, que el algoritmo ya está entrenado y lo único que tienes acceso es tú al punto donde usas el servicio, entonces tú puedes usar el postprocesamiento, técnicas de postprocesamiento para rebalancear. Pero esto es un campo de investigación, creando nuevos algoritmos
Claro.
que no discriminen. Entonces,
Pues muchas gracias.
hay mucho que se puede hacer ahí. Y CIMAT, me imagino, tiene los recursos para entrar a este tipo de investigación.
Yo tengo una pregunta, si nadie tiene preguntas. Aquí hubo una gran controversia porque una de las señoras que hizo los algoritmos para ayudar a la policía a meter en la prisión a gente, es una señora blanca, ¿no? Y a la hora de hacer sus algoritmos, pues estaba metiendo mucha gente de color en las prisiones. Una de las soluciones que la gente está promoviendo es que haya más gente de color que sea la que crea los algoritmos, ¿no? Y luego, pues sí, eso suena como una idea lógica, ¿no? Entre más gente haya que tenga menos de esos bias y le ponga menos de esos biases a los algoritmos, entonces puede ser como más fácil quitar todas esas, o sea, hacer más justos los algoritmos. ¿Pero será suficiente? Y más quería saber cuál era tu opinión en eso.
Es necesario, definitivamente, porque nosotros tenemos un montón de blind spots y yo solo pienso como mexicano, ¿no? Y tal vez el blanco solo piensa como blanco y el noruego solo piensa como noruego. Entonces, teniendo un equipo diverso, la gente le da énfasis ok, no estamos respetando a estos usuarios, ¿no? Y puedes tú defenderlos y representarlos y decir, esto lo tenemos que cambiar. Un ejemplo bastante banal, la gente había hecho de esos de que te dan jabón automáticamente y solo funcionaba para gente blanca. Ponías a alguien de color y no te iba a dar jabón. ¿Y por qué? Porque solamente los que crearon el sistema eran blancos y solamente probaron con gente blanca y no se les ocurrió pensar que hay más gente que de su estereotipo, ¿no? Entonces, tener un equipo diverso definitivamente te ayuda a pensar en qué no estamos viendo cuando vamos a crear un algoritmo. Entonces es necesario, pero no suficiente, porque tienes que hacer un montón de cosas más para garantizar que se respeta, que tu algoritmo no va a discriminar. Si te enfocas nada más en la tecnología, no ves cómo tus usuarios usan el sistema y entonces no puedes medir cómo son discriminados. Entonces, tienes que pensar sobre todo, no nada más del algoritmo.
Gracias.